Let's pick up where we left off. Let's go ahead and pick up with D here on the bottom section, so we can kind of remember what were we doing yesterday. So if you recall, my first question is going to be, can we make the bases the same? Can you make base 2 and base 7 be the same? In other words, can we use that gold paper to rewrite them? No. So what's the plan when we can't make the bases the same?
Log. Take the log.
Take the log of both sides, right? So when we take the log of both sides, I'm going to rewrite this. Log of 2 to the 3x equals log of 7 to the x plus 1. What's the step after taking the log of each side?
The exponent.
Okay, we're going to take those powers, those exponents, and move them out front. So on this first one, 3x times log of 2, which I personally am just going to write as 3x log 2. Because it's 3x and it's multiplied, you don't have to use parentheses there. When I move the x plus 1 out front, though, on the other one, you need to use parentheses. So x plus 1 times log of 7. Okay. Now as we look at this one, we've got x's on both sides, yes? What's the next step we took? Yeah. Remember, this log 7 is like a number, so we're going to take this log 7 and we're going to distribute. Okay? So 3x log 2 stays as it is. When I distribute, log 7 times x, I'm going to write as x log 7 plus, and then 1 times log 7 is just log of 7. Now what?
Factor out the x, right?
Right. Well, yes, in a moment. What do we have to do before we can factor the x out? Get them both on the same side, right? So right now, I have 3x log 2 on the left. I prefer that the x log 7 be over there with it. So in order to move this, I'm going to subtract x log 7. So then when I do that, on the left, I have 3x log of 2 minus x times log of 7. And that's going to be equal to log of 7 that remains on the right. And now I'm willing to talk about factoring the x out. So if we factor that x out, if you have 3x log 2 and you factor the x out, the remaining pieces are
3 log to the like
3 log 2 minus
log 7.
log 7 equals log 7. Okay. Last step?
Divide.
Yeah. If it's x times all that stuff in the parentheses, we're going to undo the multiplication. We're going to divide. So I'm going to divide by 3 log 2 minus log of 7. If I divide the left, we're dividing the right. Remember, what did I suggest about the denominator there yesterday? When you're put it in parentheses, right? When you're dividing and there's multiple pieces, put it in parentheses. So x is going to be whatever you get when you do log 7 divided by the quantity, 3 log 2 minus log 7. And what are we getting?
2.08.
I like the 14 answer better. 14.5727 if we are going nearest 10,000th. if you're getting the 2 answer, we did something wrong in the calculator, yes?
Yeah.
So, yeah, make sure we type in the calculator correctly, which I know, easier said than done, when there's a lot to type. Okay, so that's a little bit of review yesterday, right? We started with the top part of the notes, it was get the bases the same. The second part of the notes, we couldn't get the bases the same, so we took the log of each side. Now, when we move to the back side, here, you'll notice that there's logs in these. Okay? In the front, we're working with exponential equations. Back side, we're working with logs. Natural log of x squared minus 16 equals natural log of 6x. Any guesses? Natural log of something equals natural log of something. The insides equal each other, right? So the idea, if they're both log the same base, and it says natural log of this equals natural log of that, this and that have to be the same, don't they? So when you have 2 logs equal each other, they can't have other things added and subtracted in there, but 2 logs specifically equal to each other, we can drop the logs and just solve x squared minus 16 equals 6x. Now we have to go dig in that other filing cabinet in our brain about how do we solve this. Yeah, we see a quadratic. Good, so we're going to set equal to 0. So I'm going to subtract 6x. When I rewrite this, I'm going to rewrite it in that quadratic form of x squared minus 6x minus 16 equals 0. And what do we set up to do here? Set up to factor, right? X squared is going to break into x and x. What kind of numbers do I need? 8 and 2. And that is a positive 2 minus 8, because they multiply to be negative 16, and they add to be negative 6. Once you have the 2 factors, what do we do? Yeah. Set each factor equal to 0. X minus 8 equals 0, and x plus 2 equals 0. We're going to solve these. So the first one will add 8, the other one will subtract 2. What answers do I get? We get an answer of 8. We get an answer of negative 2. Okay. Yesterday, on the front side, at the beginning of the day, I talked about checking our solutions, yes? And with the exponentials, there wasn't really anything to check. You know, we can have negatives within exponents and all that. It was going to be okay. Today, what was my original equation? Our original equation was logs. And here's what you have to remember. What cannot be on the inside of a log? What cannot be? What? Negative. Okay? If you try and do the log or natural log of a negative value on your calculator, you get an error. Now, does that automatically mean a negative answer is a no-go? Not quite automatically, because you have to look and see what it does in our specific logs. Does that make sense? So like if I put in 8, for all I know, 8 could turn into negative value inside the log. So you need to check both. And that's just really going to be pulling it in here. If we do 8 squared minus 16, 64 minus 16 is a positive, right? 6 times 8, that's a positive. So as long as it's coming up positives on the inside of your logs, we're good. It's not that you even have to really check it to see, okay, is natural log of this, you know, just are we getting positives? What about when we put the negative in? Negative 2 squared minus 16, that's going to be a negative. Right there, I know this doesn't work. And the same would be true on 6 times negative 2. because, so I could use that one. If I say natural log of 6 times negative 2, well, that's natural log of negative 12, which is why it doesn't work, because we can't have the negative. Okay? So it's a little bit easier check than some of them we've done this year. Okay. B is very similar. The difference with B is instead of natural logs, it's log base 5. But I still have a log equal to a log. So my process, still the same, yes? Since it's log base 5 of x squared minus 45 equals log base 5 of 4x. They're both log base 5, so drop the logs, and we have the equation x squared minus 45 equals 4x. What are you in the process of doing?
Subtracting 4x.
Yeah, we're going to subtract that 4x to get our quadratic equal to 0. X squared minus 4x minus 45 equals 0. And does it factor? 9 and 5, they say. X squared is x and x. 9 times 5 multiplies to be 45. 9 and 5 subtract to be 4, make the signs happen. So minus 9 plus 5. Set each part equal to 0. X minus 9 equals 0, or x plus 5 equals 0. What solutions do I get?
5.
I'll reverse that. How about 9 and negative 5?
Right.
Correct?
Yeah.
Okay. Because they were minus 9 and positive 5 in my parentheses originally. Yeah, it's really not good for your eyes to wear glasses that aren't your prescription, just saying.
They're messing me up. They're messing my algebra game
Okay. Are both of these answers good? No? What's not good? Negative 5 is not good. And here's, I don't even have to check both pieces, guys, right there. 4 times negative 5 is a negative. So that right there is going to tell me, oops, that I would have natural log of negative 20, which does not work. Okay. 9 is going to make both sides positive. 9 times 4 is 36. That's going to be 81 minus 45. That's a positive. We're good. Okay. Now, that is your process when you have a log equal to a log. And that is a single log equal to a single log of the same base. One last change up.
Change up.
On C, do I have a log equal to a log?
Yeah. No.
No. Can I make it a log equal to a log?
Yeah. Yeah. No.
Why can't I make it a log equal to a log here? Because there's a 2. Okay, so I can make it a log equal to 2 minus a log, but I can't make it a log equal to a log. Now, how can I take this equation from having 2 logs to only having 1 log? How do we combine the logs?
They're added to multiply.
What'd you say?
Like, isn't that one thing where they're added to, like, multiply?
Mm-hmm. Remember those properties we learned back? I think it was just last lesson, but it's been several days ago at this point. 2 logs being added can be rewritten as 1 log where the insides are multiplied, right? This is product property. So log base 2, let's go back to my dark color that you guys can see. So this is going to be log base 2 of, and then this is going to be x times x minus 3. Okay, 2 logs being added can be rewritten as 1 log where the insides are multiplied. If I go ahead and clean up the inside, I have to do this at some point. X times x minus 3 is x squared minus 3x. Okay. Thoughts on how I can solve this?
I got no idea.
It's log.
Can we use left, right, middle? Now, if I recall, when I looked in Savas, and because I sometimes look at their help to see how they're going to help you, this is so not how they helped you.
No.
But, to me, the obvious easy one is left, right, middle. Because left, right, middle could take us out of log form to exponent form, and this would be a very easy one to solve exponent form. Left, right, middle says the base of 2, raise the 2 on the right, is equal to the middle of x squared minus 3x. And kind of looks like we're solving the same type of stuff we just did on the last 2 equations, right?
Yeah.
2 squared is 4. So 4 equals x squared minus 3x. Make your equation equal to 0. So if I subtract the 4 over, 0 is x squared minus 3x minus 4. Does it factor? Yeah, it factors. Four and 1. How do we multiply to get -4 and add to get -3? -4, +1. Okay. And then set each part equal to 0. And we end up with solutions of 4 and -1. Do they both work?
No. Yeah, no. I don't know. I'm just answering. No, because you have to.
Yeah.
No. Hey.
Yeah.
No.
We go back to the very, very beginning. So in other words, I'm not just going here. I have to go back to the very beginning. Right there, log of x. If log is negative, that's not working. Can 4 work? Log of 4 minus 3, both cases that's positive, so we're good there. Now, could there possibly be 2 answers on some of these? I mean, the examples we're seeing, one answer works, one answer doesn't. Realize you could have 2 answers, you could have no answers, that kind of stuff does exist. But we're finding, remember the word extraneous? These negatives are working out to be extraneous solutions. Okay, so they won't actually work in the original problem. Okay, one last one. Log base 3 of 3x minus 2 equals log base 3 of x minus 1 plus 2. Well, based on what we did on the last problem, what would be your suggestion? I like it. Subtract the log over. Yeah. So if we subtract so that the logs are on the same side, okay? So I'm going to subtract log base 3 of x minus 1 because here's what we're trying to do. We're trying to get the logs on the same side and just have the number on the other side, okay? Unless you can get a log equal to a log, which is the other option, but that's not going to work for me here. So log base 3 of 3x minus 2 minus log base 3 of x minus 1 is equal to 2. Okay, 2 logs being subtracted is written as 1 log where the insides are divided. So I have log base 3 of 3x minus 2 over x minus 1 equal to the whole number 2.
Yep.
I have a log equal to a constant, so we're going to do a left, right, middle. The left base of 3 raised to the right value of 2 equals the middle of 3x minus 2 over x minus 1. And we have the unfortunate situation of a fraction. However, it's not that unfortunate. It's doable. How do we solve? And if you're not sure, my question is going to turn into how do we get rid of the fraction? Okay. If we want to get this so there's no fraction, we want to get rid of the denominator. To get rid of a denominator of x minus 1, we're going to multiply, because it's 3x minus 2 divided by x minus 1. So I'm going to multiply by x minus 1. If I multiply one side by x minus 1, we're going to multiply the other side by x minus 1. Now, I never did the math earlier. What is 3 squared? 9. So this side is now 9 times x minus 1. The other side, 3x minus 2 over x minus 1 times x minus 1. Think of it as x minus 1 over 1, and the x minus 1s cancel, leaving me with 3x minus 2. Can we solve? Yeah. I would distribute the 9, if you didn't already. 9x minus 9 equals 3x minus 2. And okay, this is not a make it equal to 0 scenario, is it? This is, I have x's and constants, so variables on one side, constants on the other side. So if I'm trying to get my x's to the left, I'm going to subtract 3x. If I'm trying to get my constants, my numbers to the right, I'm going to add 9. So 9x minus 3x is 6x. Negative 2 plus 9 is 7. If it's 6x equals 7, we're going to divide by x, or excuse me, divide by 6. My brain wants to say x is 7/6. Homework might just want a decimal. Okay, so if we go 4 decimal places on this one, (1.166666666). So 1.1667. Okay, and if they'll let you put a fraction, that's fine. But everything else has been decimals, so I might want a decimal. Okay, your homework is lesson 6.6 in Savas. You have some time. I would say use it.